All right, so today we are talking about parallelograms a little bit more. So today we are going to be testing to see if shapes actually are parallelograms. So we're just pretty much taking what we did in 6.2 and we're taking it one step further. So today you will be able to recognize the conditions that ensure a quadrilateral is a parallelogram, and you'll be able to prove that a set of points forms a parallelogram in the coordinate plane. Just before we even get started, if you see something like this, it's a good idea to use GeoGebra. It's a good graphing software. I think it's well worth the time. All right, so we have 4 theorems to kick off. Our first one, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if our opposite sides, in this case AB and DC, are congruent, and sides AD and BC are congruent, then you have a parallelogram. Next one, 610. If both pairs of opposite angles on a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in this case, we have angle D and angle B are congruent to each other. And then we have angle A and angle C are congruent to each other. So that would also be a parallelogram. So you don't need both sets of information as long as you have one. If you can prove that the opposite sides are congruent or that the opposite angles are congruent, then you do indeed have a parallelogram. All right, the other way, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So, first things first, I'm just going to call this middle point M for middle. So, in this case, if we have DM and MB, if both of those are congruent, meaning that M is the midpoint, then, so if M is the midpoint of DB, so if DM and MB are congruent, and if AM and MC are congruent, so if M is the midpoint of that line as well, then you have a parallelogram, as long as both lines bisect each other. The diagonals, if both diagonals bisect each other. So, final way, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So, if you have one set of sides, in this case DC and AB, and if those are congruent and parallelogram, so congruent shown by that little dash mark and then parallel by the little arrow, then you do have a parallelogram. All right, so determine whether the quadrilateral is a parallelogram. Justify your answer. So right off the bat, I see 20 and 20, and I see 35 and 35. So if the two pairs of opposite sides are congruent, then we do have a parallelogram. And my reasoning would be 2 pairs of congruent opposite sides. All right, next one. So by which method would prove the quadrilateral is a parallelogram? So in this case, they show us that the top and bottom are both the same length. They're both 15, and they are parallel, which they show by this little arrow here that I covered up with my blue line. So both pairs of opposite sides are parallel. We don't know about the other pair of, well, we do, but we don't. Both pairs of opposite sides are congruent. We don't know that. Both pairs of opposite angles are congruent. One pair of opposite sides is both parallel and congruent. So the one pair is both opposite and congruent. Or, I'm sorry, is both parallel and congruent. And these aren't wildly terrible because you pretty much just have to look at the picture and say, okay, what's there? So in this case, we have opposite lines that are congruent and parallel. So we chose D, the one that said parallel and congruent. All right, so the diagram shows a car jack used to raise a car from the ground. In the diagram, line AD is congruent to line BC. So AD and BC are congruent, and AB and DC are congruent. Based on the information, which statement will be true, regardless of the height of the car jack. So no matter how high it goes, which statement will be true. So we have A and C will add up to equal 180. Sorry, I should start at the top. Angle A, so I'm assuming they mean like this right here. We're going to pretend that it's squared off at all of these. Angle A is congruent to angle B. That wouldn't necessarily be true because if the jack was like straight up, then we would have like look like this, and then angle A wouldn't be the same as angle B. Angle A and angle C are congruent. Angle A and angle C should always be congruent because they are on opposite sides. So I think that one could have a pretty good chance here. Which statement will be true? So then we have line AB is congruent to line BC. So we don't know that that's true. It could be, but we don't know. And measure of angle A plus angle C is going to be 180. So that is not necessarily true since they are not corresponding angles. A is at the top and C is at the bottom. So I would say B is our best answer in this case. All right. So find X and Y so that the quadrilateral is a parallelogram. So we're supposed to find X and Y if this is a parallelogram. So I'm going to assume this is a parallelogram, which would mean AB and DC are the same, and then BC and AD are also congruent. So if that's the case, then I would just set the top and bottom equal to each other. So I would set 4x minus 1 equal to 3 times x plus 2. Then I would also set 4y minus 2 equal to 3 times y plus 1. So let's go ahead and let's start over here on the left with the x's. So we're going to say 4x minus 1 equals 3 times x plus 2. We have to distribute into the parentheses, so I'm left with 3x plus 6 equals 4x minus 1. So we would have x equals 7 for x, and then for y, we would have 3 times y plus 1 equals 4y minus 2. So once again, we have to distribute into the parentheses, so we're left with 3y plus 3 equals 4y minus 2, which would be y equals 5. Delightful. Continuing on, find M so that the quadrilateral is a parallelogram. So if this is a parallelogram, then we know both the top and the bottom have to be congruent to each other once again. So 4m plus 2 has to equal 3m plus 8. So we would set that equation up with not a highlighter, ideally. So we would say 4m plus 2 equals 3m plus 8. We would do our equation solving magic, and we would say m equals 6. Or C. Continuing on. So this is just a summary of how we can prove something is a parallelogram. So we can show that both pairs, let me get that real quick. So we can say that both pairs of opposite sides are parallel. We can show that both pairs of opposite sides are congruent. We can show that both pairs of opposite angles are congruent, meaning top, bottom, left, right. We can show that the diagonals bisect each other, and we can show a pair of opposite sides is both parallel and congruent. So those are the 5 ways that we can show that we have a parallelogram. I suppose the 6th would be they just tell you that it is. That's my favorite way. All right. Now we get into another graphing problem. Like I said, you should do this on GeoGebra. I stand by that. That's how I would do it if I was in your shoes. Unfortunately, when I was in your shoes, GeoGebra didn't exist. So quadrilateral QRST has vertices blank, 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 and blank. Determine whether the quadrilateral is a parallelogram. Justify your answer by using the slope formula. So the way we would do this, let's just pretend we did not have GeoGebra at our disposal. The way you would need to do this is you would need to show that QT and RS are parallel to each other, meaning that they have the same slope. And then you would also need to show that QR and TS have the same slope as well. Now, there are a couple shortcuts to doing this longhand, and I will show you those right here. However, I would still use GeoGebra. So GeoGebra you can use to find the distance of each side to prove that the two opposite sides are in fact congruent. You could also use it to find slope. I haven't shown you how to do that yet, but it is a function that can happen on there. So how I do this, if I'm doing this longhand, I shouldn't say if I'm doing this longhand, if I'm doing it the cheater's way, what I'm going to do is I'm going to say for QR, from Q to R, I'm going to the right 4, and I'm going down 2. And from T to S, I'm going to the right 4, and I'm going down 2. 4, 2. Meaning that their slopes are both -1/2. And really, I don't even need to know that their slopes are -1/2. I just need to know that their slopes are the same. Now, I would do the same thing for Q, or from T to Q, and from S to R. So from T to Q, I'm going up 4, and I'm going right 1. So up 4, right 1. Now, from S to R, I'm going up 4, right 1. So those two slopes are the same. So if we have two pairs of parallel lines, and they're parallel because they have the same slope, then we can say without a doubt that this is in fact a parallelogram. And just for the record, the slope of TQ would be 4, and the slope of SR would be 4 as well. Because it's going up 4, right 1. So that's my cheater's way, the quick shorthand way of doing this.